So what are you guys?
We're the Smartwood family!
Hey guys, so as promised, I'm going to do a video on the hard version of the roundtable problem. It's kind of a classic. There's a book that does a great job on this. I think it's Counting an Introduction to Enumerative Combinatorics. Anyway, I'll look it up and I'll put a link there if you're interested. It gives an excellent treatment of this classic problem. It does it kind of like the first version of our roundtable problem, where basically what we're doing is, you're trying to show techniques and you're using those techniques to solve the problem. Okay, so what I'm going to do here is a little bit different. I'm going to basically give us this problem, hopefully, the quickest way possible, or at least a very quick way. Okay, so my take on this is, first, what is the problem? The problem is you've got a round table, and they always sit the same way around the round table, so they kind of have assigned seats. Okay, and I like to pick 3 for a quest. Okay, for those of you that like that sort of thing, this is kind of an homage to Sir Thomas Malory, the 14 Knights. I think Mallory estimates something like 140 knights at the round table. So we're going to go down to 14, okay? But you want to pick 3 knights, and there's a stipulation. So the 3 knights you pick cannot be seated next to each other, okay? So no adjacent knights, or at least no adjacent knights that are picked. Okay. All right, so how do we do this? So I think one of the quickest ways to do this is first pick a distinguished knight, because it'll help orient us, okay? So remember, they always sit the same way at the round table. So what we're going to do is we're going to pick a knight. Let's say we pick Percival. Okay. And wherever Percival is, because he's always assigned a certain seat, we're going to take him, move him around so he's at the head of the table. That'll just make life easy for us. Okay. And now, how many other knights do you have to pick? We have to pick 2 more. So they're out there somewhere. Okay. All right. Those will be the other picked knights. So how do you know which knights they are? Well, if you knew the number of knights, let's say between Percival and the first picked knight, and you number knights between Percival and the second picked knight, well, definitely you would also know the number of knights between the 2 picked knights like this, right? So if you knew this, then you would definitely know who's seated where, okay? So our goal is going to be this. Let's first look at all the knights out there. There are 14. We have placed down Percival and his 2 friends, so that's going to be 3 placed down. Now we have 11. Now the stipulation is that none of the picked knights can be adjacent. So to guarantee that, we're going to place at least 1 knight between each of the picked knights. Okay, so that's going to use up 3 more. So now we have 8. All right, but the other 8 knights, they can go wherever. And all that really matters, like if I were to place, say, 2 knights here, right? Or place 2 knights there, it doesn't really change anything because that's the same number of people, right? Between Percival and the knight on the right. So all that really matters is we're looking at these buckets again. So bucket number 1, right? Should pick a different color, huh? Bucket number 1, bucket number 2, okay, and bucket number 3. All right, so all that matters is the number of the remaining knights that we place in each of those buckets. So it's equivalent to saying, well, we've got 3 buckets. And again, I'll put links in there if you want to reference the old videos, because I'm going to assume you're comfortable with the old videos. So if I have 3 buckets and I need to place 8 knights inside of them, right? So 8, like this. How many ways can that be done? Well, we've talked about this before. You take your 8, right? And you need 3 buckets, but 3 buckets are defined by 2 dividers. So it's really going to be 3 minus 1 for those 2 dividers. Choose where the dividers go, and this would pretty much be our answer. Not quite the answer to this problem, but pretty close, okay? So now what have we done? We've set everything up. We know exactly where the knights sit. Let's make it hypothetical. Let's say we place the 8 this way. 1, 2, 3, 4, 5, 6, 7, 8. Okay, something like that. So that would place down pretty much all the knights. They sit in a certain order. So if we know where Percival is, and we know how many are to the right and how many are to the left of him before you hit the picked knights, right? Then for sure we know what this arrangement looks like. Okay. There's only one slight problem with this, and that is we made Percival distinguished, right? We said, okay, we started the counting assuming that Percival is a special knight we're going to pick. But it doesn't have to be Percival. In fact, he doesn't even have to be picked. It could have been any of the 14 knights. So to take care of that, we're going to take this number and multiply by 14, which is almost right again. But there's a slight problem. So let's say we picked for our 3 knights, Percival, Galahad, and Bors. So Percival, Galahad, and Bors. We picked these 3 knights, okay? And one way, in the way we've counted, right, we kind of picked that lead knight. So in one version of this, I picked Percival as the lead knight, and then the other picked knights might be Galahad and Bors. But we also, when we multiplied by 14, we looked at the possibility where we had Percival, Galahad and Boars, and Galahad was the one we picked. And there's also a version where we get the same group, but Boars was the one that we picked. We made the distinguished leader, okay? So because of that, we've overcounted, right? So for this group of 3, we've overcounted 3 times because we could choose any one of the 3 to sort of be the leader. So to fix that, every time we're overcounting 3 times, we divide by 3. So this is actually the solution, okay? So it's a pretty fast solution to a classic problem, but we're gonna generalize and do an even harder version. So now we're gonna have K knights, and we're gonna pick P of them, and the same rules apply. So there has to be at least 1 knight between each of the picked knights, okay? Same strategy, we're gonna pick Percival, okay, at this table. Here we go. Place Percival down, and now I'm just gonna randomly draw some other number of knights. It could be any number, it doesn't have to be, 4 of the knights, but I just wanna make my point. Okay, so here's our logic again. We have K knights, we place down Percival and the remaining knights, right, that we're gonna pick. So there's P of them. So we have K minus P knights left. K minus P knights left, okay. All right, however, we need to make sure that there's at least 1 knight between each of these. So if you have, for example, 5 guys here, you can see the number of spaces between them, or gaps between them is 1, 2, 3, 4, and 5. And likewise, if we had P knights in general, like we're doing now, we'd have P spaces between them. So we'd have to place down 1, 2, 3, 4, 5, or in general, P. Okay, so we need to place down P more knights. So now we have K minus P knights that are left. But we need to place these guys in these buckets, right? So again, if we knew exactly how many knights there were between Percival and this guy right there, right? So we knew how many were here, 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 and here. We would know exactly what that arrangement looked like. And again, how many gaps do we have here? We have 5, or in general, we'd have P. So if I have P buckets, and I need to place this many knights inside those P buckets, right? Then I need those knights plus I need P minus 1 dividers, okay? So once we have everything set up, if we choose where the P minus 1 dividers go, then we know exactly what everything looks like, okay? And in this case, negative P and positive P cancel out, so this formula looks really pretty. It's K minus P minus 1, choose P minus 1. Again, we have the same problem as before. Why Percival? Why not any of the other remaining knights? So multiply by K. But for every committee of P knights that we picked, we count them multiple times, right? Because we're distinguishing a leader, but it doesn't really matter. When you get that group of knights, there is no leader in the group. We just picked them for the quest. So the way we've counted, we said one of them was a leader. But in all those arrangements where this one's a leader, or that one, or that one, or that one, or that one, they're actually all the same. So we've overcounted P times, okay? If that's a little confusing, just go back and think about this. Remember when we picked the committee of 3, like here? We made Percival, Galahad, Boars. There were 3 different leaders for basically the same group. But we made up this whole leader idea to help us count. When you get the group of P, G, B, it's just one group, right? All right, so we go back here. This looks like the right answer, okay? Does it apply? Let's go back to the previous case we had. So in our previous case, K was 14. The number of knights picked was 3. Then we had 14 minus 3 minus 1, choose 3 minus 1. That's exactly what we had before, okay? So, but we can make this even more general. So the final version of this, let's have K knights, let's pick P of them, but now let's have S knights, at least S. So at least S knights in between each picked knight. Okay, that's my shorthand for it. So let's follow the same procedure, and this might be even quicker. So we pick again Percival. Place Percival here. Then we imagine there's some other number of knights. This is going to look identical to what we did before. Okay. So we place all of them down. How many knights do we have? Well, we have the K knights. We place Percival and the other picked knights. So we're going to subtract P. Okay. But now the stipulation is we need to have at least some number of knights between each of these. So with P knights, there are P gaps between them at the round table. Okay. And so I think, again, we need to put down at least 1, 2, 3, ... P knights in between. That worked before. Remember, between each knight, we need at least S knights. So each of these isn't P, it's really S knights in here. S knights in there, all the way around, okay? So the total number of knights we actually need to put down is SP. Okay, actually, it's not that great. Let me make it look better. Okay, is SP. Okay, so now we've seen this game before. We have this many knights to place down. How many buckets do we have? Still the same number, 1, 2, 3, 4 up to P. So it's gonna be P buckets, which is really just P minus 1. Choose where the P minus 1 guys go, the dividers. But just like before, we started Percival, could have been any of the knights, so multiply by K. But then you have this sort of redundancy, right? Because we distinguished one person, one knight, but really any knight in the group is equivalent. So we need to divide by P. When we clean this up, we're gonna get this, and now we'll get K over P times K minus SP minus 1, choose P minus 1, okay? And if we go back and plug in the numbers from before, we'll get 14, 3, 14 minus, well, P was 3, S was 1, right? That's gonna be 3. Minus 1, choose 3 minus 1, and that's exactly the same answer as before. Oops. Okay. All right, no big deal. So this is very nice. The formula is actually really pretty, and this is a classic problem. It's the most general case of this classic problem. Okay. I would also check out the book that I mentioned before. It's actually by George Martin. It's a great book. It does this differently, and it does it in a way where you're learning or practicing some new techniques. So obviously, if you want me to do that method, we can do that too. But hopefully this helped, and I think after all these videos, you basically mastered the round table problem. Okay, I'll see you guys next time.